12 marks, maths question. Scary. Save this video as part of your differential equations revision, isn't it? So, when y is 0, x is 0, solve this thing. So, in standard procedure, we need to get all the x's to this side and all the y's to this side, right? Well, you can see that this y is pinned inside the e. We somehow need to break it off. And we can do that by plussing the power, just means multiplication of bases. So I'm going to multiply through by dx, so I get dy is e to the power of x times e to the power of y cos x dx. Then this e to the y can come to this side through division. It will become 1 over e to the y, which is e to the minus y. So yeah, e to the minus y dy is e to the x cos x dx. And then we integrate both sides. Okay? This is super easy, minus e to the minus y. This one, not so much. So we need to consider that one separately. All right? And we're going to have to show this, and this is why it's 12 marks. So how do we integrate e to the x cos x dx? One of my favorite integrals parts. And there's another reason why I don't like I latte or whatever you guys say. This is an exponential and this is a trig. You can clearly see that you're going to be leaving the exponential here so that I latte stuff doesn't work, and which is why I don't remember those silly kind of rules. The rules I show you though, they're legit. Like Liddy, for example. Bypass. So we leave the first term, integrate the second. So we think about what differentiates to cos is sine. And then we differentiate the first term, and these are always the same. So we have to integrate e to the x sine x. Unfortunately, we're going to have to do the same process again. So let's look at some Liddy in that. So we leave the first term, integrate the second. Now this is going to be minus cos x this time. And then we differentiate the first term. And then these two brackets are the same. Interesting. We are left with the beginning. This is a cyclic integral. So we're just going to write down our full integral, and then we're just going to do a bit of rearranging, and then we're done. So we get e to the x cos x dx is e to the x sine x minus this integral, which is the negative of all of this. Okay? Now this minus comes out there to make it a plus. All right? So we get the negative of this, but there's already a negative there, so it's going to become plus e to the x cos x. And then that plus, with that negative there, it's going to become minus the integral of e to the x cos x dx. That comes to this side to make it 2. And I'm not going to write the whole thing again. It's going to become 2. And then we're going to divide by 2, and then we have our integral. All right? So, we have what? We have that the integral of e to the x cos x is e to the x over 2 sine x plus cos x. Okay, beautiful. So that is going to go here. This, I have minus e to the minus y is e to the x over 2 sine x plus cos x w plus c. And you could have written in any of the sides, okay? Then it says when y is 0, x is 0, solve. I think they wanted it, I don't remember from the question, to be honest, what form it wanted in, but we'll decide which one looks nicest. So now when we sub in 0, 0, what do we get? E to 0 is 1, so we get minus 1 is 1 over 2 sine of 0 is 0 plus 1. So that's just a half times 1, so we get a half. We get minus the half, minus 3 over 2. So, I'm just going to sub that in here. So, minus 3 over 2. And that's that negative one. So, I'm actually going to times by minus. Oh, the over 2's mean they can come into one denominator. So, I get e to the minus y. Now, I'm going to reciprocate this after. Is over 2. So, I'm going to get 3 minus e to the x sine x plus cos x. Then that means e to the y. I think this is going to be our final solution. Can you guys see over here? I hope so. Anyway, I'll read it out to you. So e to the y is 2 over 3 minus e to the x sine x plus cos x. And I think this is the form they would want you to leave your answer in. And that is my solution for 12 marks. Save this video as part of your differential equations revision and cyclic integrals. It's a very important question. Nice.